Physics chapter 30, theory video 3. Now we are going to discuss about improving X-ray images. Now the complex X-ray machines that we have in the hospitals today, they don't use that simple technology that we discussed earlier. That is, just passing the X-ray through and recording whatever that comes out of the other side. There are highly developed technology attached to these X-ray machines in modern day hospitals. So there are machines that you can actually see how bone, not only the bones but also blood vessels and the bowels and etc. that also can be observed. So the radiographers have two aims to do this. The first thing is to minimize the possibility of patient's exposure. So the patient is getting exposed to this because of the ionizing radiation. It is not good. It is cancerous. But when you get exposed for a longer period of time, people develop cancers. For example, nurses develop cancers because of this. Then the second one is to improve the contrast of the image so that the different tissues can be seen separately, and there is a difference between the soft tissues, because if all the soft tissues as seen as a single lump, then it is of no use. Then to reduce the dosage of the X-rays, there are many things that have been developed. At the earlier stages, patients had to be exposed for a longer period of time because these X-rays are not easily absorbed by the film. But now there are something called an intensifier screen that is being used. This contains phosphor. Phosphor is a substance that emits visible light when it absorbs X-ray photons. So there is a film sandwiched between two intensifier screens. So when each X-ray photon is absorbed, it results in thousands of light photons. This light photon will blacken the film. So as a result, what happens is the energy is intensified. So that reduces the patient's exposure, and they say that the patient's exposure is reduced by about 100 to 500 times. So in digital systems, that is much more stronger. There are image intensifiers that can be used. So that is when X-ray strike a phosphor screen, again visible light photons are produced. So they will, by photoelectric effect, they will release electrons from the photocathode. They accelerate and will be focused on a positively charged anode. So there is a screen. That screen will give out visible light, and this image on the screen can be seen on a camera, and at the same time it can be recorded. So they can be shared, stored and viewed, and in present day scenarios, it can be easily sent out. So this is an X-ray image intensifier. So as you can see, electrons are focused onto the anode, and they can be easily seen. So these are this image intensifier is actually a very useful technique. Useful in a technique known as fluoroscopy. In fluoroscopy, a continuous X-ray beam is passed through onto a fluorescent screen where a real-time image can be formed. So using this image intensifier, we can actually move the arm or sweep, without taking several X-rays. We can move the arm or whatever it is that is broken, or if we have to observe it, we can rotate it and move it, and then see how at different stages it is shown. So that is actually something quite important, and these image intensifiers or intensifiers in general will reduce the exposure of a patient to X-rays. Then improving contrast is another important thing, because if there is a good contrast, that means there is a clear difference in the blackening of the photographic film, and there is a clear difference between soft tissues and different kinds of soft tissues and bones. So the contrast is actually determined by the hardness of the X-rays. Bones absorb the radiation well. So if a bone that is broken is to be observed, then the doctor will use hard X-rays, because that is, we are talking about hard. We need to see the bones. So if the tissues of the breast is to be seen, the breast is actually the tissues in the breast are going to be really soft, and it's a poor absorber. It will actually require long exposure, and it is not good. So instead of sending out hard X-rays, it will be a softer X-rays will be sent that would have long wavelength, low frequency X-rays. So you can understand that there is a hard X-ray as well as soft X-ray. So then we have seen that these X-rays can show different tissues. We can understand them. We can understand that this is one tissue. This is a particular type of tissue. This is the blood vessel, etc. We can figure them out. That is because against the soft tissues, there are some muscle fibers which can absorb these X-rays better than other soft tissues. So there is something called contrast medium, something like iodine or barium. So which is a good absorber of X-ray. So if you swallow a barium liquid or have a barium meal, then what happens is that barium would go into the tissue of interest, and then it would become a better absorber of X-rays, and so as a result its edges would be shown really clearly on the final image. So these are the things that have been done to improve the quality of the X-ray. So now here in this picture, it is shown a patient who has drunk who has taken a barium meal. So the intestines are shown where these pale areas that show the places where barium is concentrated or collected. Other parts of the intestine, they are in those parts also barium is present. So as a result, we can see the outline of the tissue very clearly. But if barium has not been taken, it wouldn't have been shown like this, because the outline would not be seen by us. So if there is any damage, any tissue damage or anything, we can see this very clearly. Usually these contrast media are elements with high atomic number Z. So that means there are many electrons with which X-rays can interact, so they become more absorbing. Because soft tissues mainly contain hydrogen, carbon, and oxygen with low atomic numbers. They do not become, they don't absorb well. So if there are heavier elements, calcium and phosphorus, they have higher Z values. As a result, bones attract them better. So as you can see, soft tissues, the average Z is 7. So it does not absorb well. Bones, its average is 14, so it absorbs better. Contrast media, they have an average Z of 55, that they absorb even better. So let's write down a note on this before going to the question. X-ray images can be improved by using various mechanisms. The objective is to reduce the patient's exposure to harmful X-rays and to improve the contrast of the image so that different tissues can be observed clearly. Leave a line and write. X-rays, like all ionizing radiation, can cause damage to living tissues, cause mutations, and form cancerous tissue. Therefore, to reduce the dosage of X-rays, image intensifier screens are used which contain phosphor, which absorbs X-rays and release light photons within brackets, right? For each X-ray photon absorbed, several thousand light photons are released. This accelerates and intensifies the blackening process, reducing the patient's exposure. In digital systems, leave a line and write, in digital systems, image intensifiers are used when X-rays strike phosphor screen, they produce visible light photons. These in turn release electrons by photoelectric effect, which get accelerated towards a positively charged anode, which when struck on a screen gives visible light, converting it to an image. This can be viewed live as well as recorded. Leave a line and write. Fluoroscopy is a real-time image viewing which uses intensifiers to observe the X-ray beams that pass through a patient onto a fluorescent screen. Leave a line and write. When contrast is better, there is a clear difference in the blackening of the photographic film when X-ray passes through different types of tissue. When bones are to be observed, hard X-rays are used, but when soft tissues such as the breast tissues are observed. Soft, within brackets, long wavelength, low frequency X-rays are used. Also, heavy atoms such as barium or iodine are good absorbers of X-rays, and if a patient swallows a barium containing liquid or injected to the tissue of interest, their edges are seen clearly because they are better absorbers. Right. I want you to draw this figure 30.6 and get a better idea of that. Right. Once you have completed that, please do question number 6, 7 before we move on to the next topic.